So, good day everyone. In today's lesson, we are going to tackle integration techniques. So for this lesson, we have 5 types of integration techniques. First is integration using substitution or U-sub. Second is integration by parts. Third is using Trigo substitution. Let's put it here, Trigo substitution. Fourth is using partial fraction. And lastly, double and triple integral. But first, we are going to discuss the number one technique here, which is integration by using U-substitution. So let's do that. So U-sub here, U-sub substitution. So our formulas for U-substitution is just the integral of U du is just equals to U raised to n plus 1 over n plus 1 plus c. This type of formula is called general power formula. Second is the derivative, the integral of du over u, which is just equals to ln of u plus c. This is logarithmic. And number 3 here we have integral of e raised to u du is just equals to e raised to u plus c. This is just exponential. Now let's move on to our first example here. Example number 1, the integral of, let's say, e raised to 5 minus 2x. So our u here can be found on our exponent in the denominator and in our algebraic form. So u here is our exponent, which is 5 minus 2x du. The derivative of 5 minus 2x is equals to negative x. 2x 2x no, it's 2 dx, 2 dx, negative 2 dx. So we have an excess here, so negative 2 dx, so we put a balancing factor here to balance the equation. So let's rewrite our equation here. Don't forget to put the balancing factor outside, then the integral of e u du is just equals to, we substitute u here, so it goes to negative 1/2 e raised to u. So we substitute back our u. Our u here is 5 minus 2x, so negative 1/2 e raised to 5 minus 2x plus c. So this is our answer for our problem number 1. Problem number 2 here, let's say we have let's say we have 2 over x squared minus 2, or x, or 2x I mean, or 2x dx. So as I said earlier, our u can be found on the denominator, in the exponent, and in our algebraic form. So u here, our u here is in the denominator, so u is 2x. Our du here is just equals to 2 dx. So there are no balancing factor here because 2 dx here is the same as 2dx here. So let's rewrite our equation to the integral of du over u, which is just equals to ln of u plus c. Let's substitute back our u here. Our u here is 2x, so ln of 2x plus c. This is our answer for problem number 2. Moving on to problem number 3. Let's say we have here the integral of x dx over 4x squared plus 1 raised to 5. So our u here is 4x squared plus 1, as I mentioned earlier. So 4x squared plus 1, and the derivative of 4x squared plus 1 is just equals to 8x dx. So our derivative here is 8x dx, while in the original equation it's x. So there is a balancing factor here, which is 1/8. So guys, balancing factor here, if your du is equals to a whole number, your balancing factor must be a fraction to cancel each other out. Let's say here, let's put here 8x. So what we will do to cancel 8 here, 8 here, so we'll put 1/8 outside. So 1/8 and 8 will just cancel each other out, which will become 1. So erase this. So let's write our new equation here. This is equals to 1/8 over du over u raised to 5 integral. This is integral. So du over u here, because our u here as an exponent of 5, so let's move our u outside. This will just become u raised to equals to 1/8. Don't forget our balancing factor, and the integral of u, because we move u raised to 5 up, we need to change its sign. So by remembering our general power formula, which is here as you see in here, u du, which is equals to u, the n here is our exponent, plus 1. So -5 plus 1 over -5 plus 1 will just equals to 1/8 u raised to -4, or we could just rewrite that as let's say here u raised to -4 over -4. So 1/8 and -4, let's rewrite this here. 1/8 times -1/4. We move u here, u raised to 4 below, so it becomes u raised to 4. Will become a positive exponent. So 1/8 times -1/4 is just equals to, say, 4 minus 1 by 4 minus 8 is equals to 8 times 4 is just 32. So 4 minus 8, or this will become plus 12 over 32 u raised to the 4, or we could simplify this as 12. Common factor is 4. So to be sure, let me use my calculator. You cannot see that. So I'll just 1/8 times -1/4 is equals to -1 over 32. -1. So this becomes -1 over 32. is wrong. So negative 1 over 32, and our u here, we transfer it to the bottom where u raised to 4 plus c. Now we substitute back our u. Our u here is just equals to negative 1 over 32. U here is 4x squared say here, negative 1 over 32, 4x squared, this is our u, 4x squared plus 1 raised to 4 plus c. So this is our answer for our third problem. Now let's move on to the second type of integration, which is integration by parts. Integration by parts. So guys, did you find u sub easy? Because this is the most basic, or this will help you a lot by solving u substitution. You can solve other problems in our future discussion. So integration by parts, let's say. So let's first discuss the principle of integration by parts. So our formula for our integration by part is just equals to an integral of u dv equals to uv minus integral of v du. So this is our formula for integration by parts. So I will teach you how to use this formula in our examples. Let's start. Let's say number 1 here, we have the integration of ln x dx. So how do you determine your u and your dv? It's simple. Our u is usually found on the first type of, on the first number or first equation in our first problem. So u here is ln of x, so u ln of x, and the derivative of that is just equals to 1 over x dx, and our dv here is dx. So now how do we get the v here? We'll just integrate our dv. So our dv here is dx, so dx, the integral of dx is just equals to x. Now we have our values, so we're using the formula uv integral of u dv is just equals to uv minus the integral of v du. So equals, our u here is ln of x and our v is x. So let me rewrite that as x ln of x minus the integral of x dx over x. Now since x here and x here will just cancel out, let me simplify this, x ln of x minus the integral of dx. So this will just become, the integral of dx is just equals to x ln of x minus x plus c. Don't forget your c here, because c here is very important. So this is our final answer for problem number 1 under integration by parts. Let's move on to number 2. Number 2, let's say we have x, integral of x cosine x dx. So our u here is just equals to x, and our du, or the derivative of x, is just equals to dx, and our dv here is equals to cosine of x, and then the integral of cosine x dx is just equals to sine x. Now we have our values. Let's rewrite that as uv. Our uv here is x sine x minus the integral of v du, which just equals to sine x dx. So x sine x minus the integral of sine x is just negative cosine x. So by simplifying this even further, our final answer will become x sine x minus sine here, and minus sine will just become positive x sine x plus cosine of x plus c. This is our answer for our problem number 2. Now we move on to problem number 3. Let's say we have x5 x raised to 5 integral of x raised to 5 ex dx. So x raised to 5 ex dx, we'll use a method here that my teacher taught me, which is di method. D here stands for the derivative of our u, and I here stands for the integral of our dv. So let's do that. So our u here is just x raised to 5, and then the integral of our dv here is just ex, e raised to x, I mean. So now we derive x raised to 5 until it reaches to 0. So let's do that. 5x 4, and the integral of 5x raised to 4 is equals to 20 x cubed until we reach 0. Is 120x, and this is 120 and 0. And the integral of ex here is just ex, e raised to x, I mean, e raised to x, e raised to x, e raised to x, e raised to x, e raised to x. Now we plot our signs here. This is just what becomes positive, negative, positive, negative, positive, negative, and positive. Never mind the 0. So how do we solve this? So by doing this, the first number will multiply to the second number of our I here. So it's just this. So x, 5x, multiply this, multiply this to this, and this to this. Now by plotting in the values, say we come here, so by plotting the values, don't forget our sign here. So x raised to 5 ex, e raised to x, minus 5x raised to 4 e raised to x plus 20 x cubed e raised to x minus this minus 20e and minus 60 x cubed x squared ex plus 120 x e raised to x and minus 120 and plus c. Don't forget our c here. So for this type of problem or equation, we use di method. So di method is only used when RU is an algebraic form, and RdV here is just exponential or algebraic or logarithmic. Now this is our answer for problem number 3. Now let's move on to our third type of integration of techniques, which is trigonometric substitution. Trigonometric substitution. So trigonometric substitution, for this and in this type of integration technique, there are 3 types of trigonometric substitution. First type is type 1. If the integrand contains a squared plus x squared, a here is our constant, this we use, and x here is our x, we use x equals to a tangent theta. So now let me give you an example of type 1 trigonometric substitution. So number 1 problem for type 1 is the integral square root of, let's say, 1 plus x squared dx. Now we use x here as a tangent of theta, so x equals to our a here is 1, so the square root or the square root of our square root of 1 is just 1. Let's say 1 plus, oh no, we substitute this x here, so 1, our a here is our 1, so the square root of 1 here is just 1 tangent theta, and the derivative of 1 tangent theta is just equals to 1 secant squared theta. So now we have our values here, so let's rewrite this equation to square root of 1 plus x here is just 1 plus tangent theta, let's put that here, 1 plus 1 tangent, I mean theta squared dx. Oh no, our dx here we put here beside, we substitute our dx to its value here, so dx is 1, or simply secant squared theta d theta. So by simplifying this, square root of 1 is just equals to 1 plus tangent here squared, if we square this it will become tangent squared theta, and when we cancel this, when we square root, tangent squared theta is just equals to tangent theta secant squared theta d theta. So now what do you guys do next? So we need to use substitution here. So RU here is just equals to tangent theta, and the derivative of tangent theta is just secant squared theta d theta. So we took 1 outside, it become 1. So the derivative of this is equals to the integral of integral u du. So by using the general power formula, u here 1 plus 1 over 1 plus 1. So u is this is just equals to u squared over 2 plus c. So we substitute back our u, which is tangent theta squared over 2 plus c. So guys, what do you think is the... So do you guys think this is our final answer? No, that's right, no. We need to find the theta, the value of theta here. So let's do that by taking out this function. So x equals to 1 tangent theta. So if we transfer 1 here, this will become tangent of theta equals to 1 over x. So by transferring theta outside, our theta here, oh no, I think this is the final answer, because tangent of theta here is equals to 1 over x. So let's finalize our answer, which will become 1 over x squared over 2 plus c. And this is our final answer. Final answer for our problem number 1 under trigonometric substitution. Now, let me give you one more example of this. So example number 2, we have let's say, so this is our problem number 2. The integral of x squared over the square root of 9 plus x squared. So let x become our a here is equals 3, because a squared is 9. So a tangent theta, we replace x to a tangent of theta, and the derivative of that is just equals to 3 secant squared theta. Now by replacing x here, this will become 3 tangent squared theta over the square root of 9 plus x here is 3 tangent of theta, 3 tangent of theta squared. Now we simplify this equation. So 3 squared is equals to 9 tangent squared theta over the square root of 9. We erase this. Plus 9 tangent squared theta. Oh, we forgot to put dx here. So our dx is just 3 secant squared theta. Now we square root r. Now we simplify the denominator. So this will become 9. We put 9 outside because it's a constant. 9 integral of tangent squared theta 3 secant squared theta over 9 here will just come 3 plus 3 tangent theta. Now we have here a common factor. Let's take this out. It will become 3. So this will just become 3 tangent theta. Now we take 3 outside. That will become 9 over 3. It's just simply 3. So 3 the integral of tangent. So tangent theta here will cancel out this, and what will left is just equals to integral of tangent theta 3 secant squared of theta. Now we also need to take 3 here outside because it's a constant. Our answer here is just integral of tangent of theta secant squared theta d theta. Right, tangent d theta. Now we have here just a U substitution. So our U here is tangent theta, and our du is just equals to secant squared theta d theta. So this will just becomes integral of u du 9 the integral of u du, just using the general power formula. This is 1 plus 1, and this will become 9 times u squared over 2 plus c. So by simplifying this and putting our u here to our original equation, this will become 9 halves times tangent theta squared plus c. But we are missing tangent theta here, the value of tangent theta. So how do we do this? It's easy. Just take this equation here. Let's put it here. Equals to x equals 3 tangent theta. Yes. Now by dividing 3 here to cancel 3 and 3, we must also put here 3, and this will become tangent theta over x equals to x over 3, and this is the value of our tangent theta here. So this will becomes 9 over 2 x over 3 squared plus c. So by simplifying this even further, let's say 9 halves x squared over 9 plus c. So by simplifying this, 9 halves times x squared over 9 here will just cancel each other out, and this will become x squared over 2 plus c. This is our answer for our problem number 2 under type 1 under trigonometric substitution. Now we move on to type 2. So if type 2 here is, if our type 2 of our integrand contains a squared minus x squared, we use x equals to a sine theta or x equals a cosine of theta. we use this transform or substitution. So let's have here a example. So here is my example number 1 for you guys under type 2 integral substitution. So let x becomes 4 because a here is 4 and the a squared is just 16. So 4 minus 4 sine theta, and the derivative of this of 4 sine theta is just equals to 4 cosine theta d theta. So equals to let's say here x here is 4 sine theta squared and square root of 16 minus 4 sine theta squared 4 cosine theta d theta. So 4 sine theta raised to 2 is equals to 16 sine squared theta. The integral of this is the integral. So by inspection, square root here we just cancel this out, and the square root of 16 is just equals to 4 minus 4 sine theta 4 cosine theta d theta. So by taking 16 out, this will become 16 sine squared sine squared no, let's not simplify this is wrong. So the square root of 16 minus 16 squared theta, 16 sine squared theta. So this will become 16. The integral of sine here is just that we use substitution. U here is simply just sine squared, sine theta mean, and the derivative of that is just cosine theta d theta. So this will become u squared theta now we take out the common factor here, which is equals to 4 for integral of negative u here, u squared u sine 4, yes, cancel out, this will cancel out, this is 4, take 4 outside, so 4 negative u du. 16 times 4, we take out this constant and we'll multiply this, so this will become 16 times 4 just 64. Let me find my calculator in order to make sure. So 16 times 4, yes, it's 64. Integral of u squared plus 1 over 2 plus 1 times for the integral of negative u 1 plus 1 over 1 plus 1. This will become 64 u cubed over 3 times 4. The integral of this is just equals to negative u squared over 2 plus c. Oh guys, don't forget the theta here. Okay, theta, and this will become 64 over 3. We substitute back our u here to our original equation, which is sine cube theta times 4 over 2. That will become cancelled out, so 4 and 2 will cancel out. That will remains 2 times negative sine squared theta plus c. Now we need to find theta here. So theta here, by using this equation, is equals to x equals to 4 sine theta. So we divide 4 here and we divide 4 here. That will become sine squared theta is equals to x over 4. Now we transfer sine here. That will become theta equals to arc sine x over 4. Now, by simplifying this even further, our answer will become arc sine 64 over 3 arc sine of x over 4 times 2 negative arc sine negative arc sine x over 4 plus c. Now this is our answer for our problem number 1 under type 2 integration by substitution. Now we move on to type 3, which under trigonometric substitution. If type 3 here, if the integrand contains x squared minus a squared, we will use x equals to a secant of theta. So what do you notice in type 2, in type 3 between type 1 and type 2? So in type 3, the constants are reverted or transposed to each other. So let me give you an example in order for you to understand. So this is our example for type 3. So the integral of dx over square root of x squared minus 9. So we let x here becomes a here is 9, a here is 9, and the square root of 9 is just equals to 3 secant theta, and the derivative of this is just equals to 3 secant theta tangent theta. So now we have our values here. So this will become dx here is 3 secant theta tangent theta d theta over the square root of x here is 3 secant theta squared minus 9. So this will become 3 secant theta tangent theta d theta over square root of 9 secant squared theta. I just squared here the equation. Secant squared minus 9. Now we forgot to put here the dx, which is equals to 3 secant theta tangent theta d theta. 3 secant theta secant theta tangent theta d theta. Now we are ready to integrate this, but first we need to factor this out. So let's do that. So we move 3 here and 3 outside, that will become 9. Integral of secant here and secant squared, secant tangent here will become secant squared tangent theta d theta over square root of, let's say we factor it out, 3 secant squared theta. Now we move this 3 outside, that will become 9 over 3, and that is just equals to 3 secant squared theta tangent theta over secant squared theta. So secant squared theta here and secant squared theta will just cancel each other out, and that will become 3 the integral of tangent theta d theta. So the integral of tangent theta is just equals to secant squared theta plus c. Now we need to find the value of secant theta here. So by putting this below, x equals to 3 secant tangent. So we put 3 here, that we cancel out. So secant theta is equals to x over 3, and the value, now we transfer secant here outside, that will become theta equals to x over, that will become arc secant x over 3. So by finalizing, our answer will become secant, or let's say arc secant squared, x over 3 plus c. So this is our answer for our problem number 1 under type 3. Now we move on to another integration technique, which is using partial fraction. So let's do that. So partial fraction. In this type of technique of integration, there are three cases of partial fraction. First case is case 1, the distinct factors. So when n here is a constant or a equation, n is all over x minus a, x minus b, and x plus c, or whatever. It could be it could be negative or positive. So this will become a over x plus a plus b, x plus b. Let's say here this is negative b plus c all over x plus c. So if the factors of your denominator is repeated, use case 1, and that is distinct factor. So let me give you an example. Let me here number 1, the integral of let's say 2 over x squared minus x cubed minus 2. Oh no, this is wrong. X cubed minus x minus 2. So first we are going to factor this out. So this is a quadratic formula, a quadratic equation. So let me factor that out. This will becomes x minus 2 and x plus 1. So x squared, so this is x, this is x squared plus x minus 2x minus 2. So this is our new equation over 2. So this will becomes a over x minus 2 plus b over x plus 1. Now we are going to find the value of a and b by using a method that my teacher taught us, which is a cover up method or CUM. So cover up method is, example here, a is equals to 2 over, so we cover up 2 here, x minus 2, the value of a, cover this up, and what will left is only x plus 1. Now we need to value the value of x here is just the value when a number is subtracted from this number, that will become 0. So 2 minus 2 equals 0, so let's put 2 here, and then the value of our a is just equals to 2 over 2 plus 1, which is 3. Now this is our value for a. Now let's move on to b. So b here is 2, we cover this up, x plus 1 there, x plus 1, and the value that will be left is only x minus 2. This is x minus 2, and the value of x here will be the number that will be subtracted from 1, that will become 0. So negative 1 plus 1 is 0. Let's put negative 1 here. This will be equals to 2 over minus 1 minus 2 is just equals to negative 3. So our answer here is negative 2/3 for the value of b. Now we are ready to integrate this value. So 2/3 over, we substitute a here to this because this represents our value of a. 2/3 over x minus 2, the integral, plus b here is negative 2/3 over x plus 1. Now this, so by integrating this, our answer will be 2/3 1 over, I take 2/3 outside because it's a constant. Now what is left here is 1 over x minus 2. So the integral of 1 over x minus 2 is just equals to ln of x, which our x is just x minus 2, plus, let's say minus, because the sign of our constant here is negative, so negative 2/3. Oh no, this is the wrong pen. Negative 2/3 ln of x plus 1, x plus 1 plus c. So this is our answer for our problem number 1 under case 1. Let's move on to another example here. Let's say the integral of 2x over x plus 3 and x minus 2. So this will become a over x plus 3 plus b over x minus 2. So we will find a by putting the equation here. Now by using the cover up method, x plus 3 will cover x plus 3, and what we will left is x minus 2. And the value of x here must be equals to 0 must be 0 when the value we pick will become, let's say, negative 3 plus 3 equals 0. So let's do that. Negative 3. So this will become 2 times negative 3 is negative 6 over negative 3 minus 2 is negative 5. And by simplifying that, our answer will be positive 6 over 5. 6 over 5 is for value of a. And now for letter b, this is just 2x, and using the cover up method, let's say here x minus 2, let's cover x minus 2, what will be left is x plus 3. Now the value of x here is just 2 because 2 minus 2 equals 0. Then by substituting x, this become 4 plus 3. 2 plus 3 is 5, so 4/5. Now this is our value for our a. This is a and b. Now we move on to integrate them. So a here is 6 over 5 over x plus 3 plus b here is 4/5 over x minus 2. And by integrating this, our answer will become 6 over 5. We take out the constant, and the integral of 1 over x plus 3 is just ln of x plus 3, x plus 3 plus 4/5, and then 1 over x is just ln of x, so ln of x minus 2 plus c. This is our answer for our problem number 2 under type 1 in partial fraction. Now let's move on to the case number 2. Now we have here case 2, which is repeated linear factors. So if n here is all over x squared times x minus 1 raised to 3, this will become a over x plus b over x squared plus c x minus 1 plus b over x minus 1 squared plus c over x minus 1 cubed. Now we move on to the first example, which is, let's say, x, the integral of x dx is equals to x plus over x cubed, so x squared plus x minus 1. Now a here, this will become x plus b over x squared plus c, which is x minus 1. Now we use the cover up method. So we only use the cover up method when our denominator here in our equation is the same as in our denominator here. So let's put first b here. So b here, covering up this method, covering up, this will become x over x plus 1. Right? Oh no, x minus 1. X minus 1. Oh, let's change our problem. This will become 2 dx of 2. So looking at our equation here, b here must be equals to 0. So what value becomes 0? So this is equals to 0. So 2 over negative 1 is just negative 2, equals to negative 2. This is our value for our letter B. And now for C, we have 2 over, by covering up this and this, what will be left is x squared. So x squared. Now 1 here minus 1 is just 0, so let's put that 1. So 2 over 1 squared is just equals to 2. Now we find our value a here by using substitution method. So we find first the LCD of this equation, which is equals to x squared times x minus 1. Now we apply this. So x squared here and x will just cancel out. What will left is just 2 over x squared, a x and x minus 1 plus x squared here will just cancel out. What will be left is b and x minus 1 times x minus 1 plus c. X minus 1 will just cancel out each other out, and it's x squared. So by simplifying this even further, this will become a times x squared minus 1 plus b times x minus 1 plus c x squared. No, let's replace our b here and our c. Our b here is just negative 2, so this is negative minus 2, and our c here is just 2. Now we are ready to find our value a, which is become x squared. Oh no, x, I mean x. So if x equals to 0, our x here becomes also 0. X here is a, x here is negative 2, and x here is just plus 2. No, there's nothing here. So RA will become, what number will become 0 when it minus 2, negative 2, which is 2. Say 2 here. So now we have our values for our problem here. So let's rename that here. The integral of 2 dx over x squared times x minus 1 is equals to, a here is 2, so 2 over x integral, plus b here is negative 2 x squared, plus c here is 2 also, c is c over x minus 1. Now our answer is just equals to 2. Integral of 1 over x is just equals to ln of x. This is negative 2 minus 2 ln of x squared, 1 over x squared. Oh no, 1 over x squared. So this is not ln. So let's integrate first the second value. So integral of 1 over x squared, this will become x raised to negative 2 plus 1. This will become negative 2 plus 1, 1. So this will become 1 over x negative 1 over x. Yes, that's correct. This is negative 1x. So negative 1x times negative 2 is just positive 2 over x, plus 2 1 over x minus 1 is just equals to ln of x minus 1 plus c. So now this is our answer for problem number 1 under case 2. Let's have another example here. So this is our problem number 2 for case 2. X integral of x plus 1 over x cubed times x minus 1. So first we are going to draw here a plus over x plus b over x squared plus c over x cubed plus d over x minus 1. Now we can use cover up method here, which is just the value of c and d. So using cover up method, okay, so cover up method, c here is equals to x plus 1. So we're covering x cubed here is x minus 1, and the value of that is just equals to 0. X here must be 0, so 0 is the best value there, so 0. So 1 over negative 1, just negative 1. So let's move on to the third d here. We're covering this up, x minus 1, x plus 1 all over x cubed. So the value of d here that must equals to 0 is just x equals to 1, and this will become 1 over 1 just equals to 1 plus 1 equals to 2. So 2 over x over 1 raised to 1 cube just equals to 2. And now by using coefficient method, by multiplying the LCD here, which is x cubed and x minus 1, x plus 1 here, this will cancel out, so x plus 1 is equals to a x cubed here, and x here will just cancel out, so this will become x squared x minus 1 plus b x cubed over x squared is equals to x times x minus 1 plus c x cubed and x cubed will cancel out, so we left is x minus 1 plus d, which is x cubed. So now we replace the value of our c and d here. This will become, and simplify all of this will just become to a, by multiplying this will become x cubed minus x squared plus b here is, by multiplying this will become x squared minus x. Our c here is negative 1, so minus 1 is just 1, so x minus 1 plus d here is positive 2, so this is 2 x cubed. Now we are going to find the values of each is. So x cubed here in a, the first value x cubed, so let's replace a to x cubed. So this x cubed is found here, so no, this is become 0 equals to x cubed found here, yes, that is just equals to a plus, is x cubed found here, no, let's leave it out. Is x cubed found in here, no, let's also leave it out. Is x cubed found here, yes, that is plus 2. So our a here, a must be equals to negative 2, a must be equals to 0, so negative 2 plus 2 is 0, so a here is negative 2. And for our b, the first value is x squared, so x squared is equals to, is x squared found here, this 0. Is x squared found here, yes, that is negative a plus, is x squared found here, yes, that's b, and nothing more. So our a here is negative 2, so negative 2, let's place that as negative 2. So negative 2 and another negative, that will become positive 2. Illustrates that, so this is positive 2. So what number of b must be subtracted to the 2 that will make 0, so that is just negative 2. So equals, b is equals to negative 2. So now we have our values. A is negative 2, b is negative 2, c is negative 1, and d is 2. So now by moving this equation here, you see it, a here is just negative 2 over x. Now we are ready to integrate, plus b here is negative 2 over x squared, plus c here is negative 1, so it's just negative 1 minus 1 over x cubed, plus d here is 2 over x minus 1. Now we are ready to integrate each one of them, so this will become negative 2, we put outside, and 1 over x equals to ln of x, plus negative 2, and by integrating this problem, x here become x squared, come above, so negative 2 plus 1, negative 2 plus 1, that will become 1 over x, or 2 equals to negative 2 over x, plus So this is negative 2 plus negative 1 here. Let's put negative 1 outside. That will become negative 1. X cubed here become negative 3 plus 1, negative 2, negative 3, negative 2. This will become negative, and negative will just same signs add, so this will become positive plus 1 over 2x squared plus 2 ln of x plus 2. So 2 here we put outside, and the integral of 1 over x minus 1 is just equals to ln of x. So let's do that. Ln of x, ln of x minus 1 plus c. So this is our answer for our problem number 2 under case 2 in partial fraction. So let's move on to case number 3. Case 3 is just what quadratic factors. So if n is over a quadratic equation which is equals to ax squared plus bx plus c squared, this will just become a over ax squared, a times the derivative of our denominator, which is just equals to 2a plus b over ax squared plus bx plus c plus b all over ax squared plus bx plus c. Now we move on to our first example, case number 3. So if we have here, let's say 3, the integral of 3 over x minus 1 times 2x squared plus 9, this will just becomes to a over x minus 1 plus b, the integral of this denominator is just equals to 2x over x squared plus 9 plus c over x squared plus 9. Now by using coefficient method, we need to find first its LCD, which is just equals to x minus 1 and x squared plus 9. So three here, so by multiplying this will cancel each other out, so what we'll have is 3 equals to x minus 1 will cancel out. This will become x squared a times x squared plus 9 plus b to x squared plus 9 will cancel out, so what we'll have is x minus 1 plus c and x minus 1. So by simplifying this even further, a here plus to x squared plus 9 plus b times 2x, and by multiplying this these values, this will become 2x squared minus 2x plus c times x minus 1. And by using our calculator, let's say here, can you see my calculator? Oh no, wait. But first, we need to find the value of x squared and x and the constants, which is, let's say, c. C here represent constant, so x squared. So can you see my calculator here? So first let's go to mode and set to equation and type 2 here. 2, press 2. Now we have our equation here. Let's say a here, the value of x squared, let's say x squared here is our first, so ax squared here is just 1, x squared here is 2, you see it, 2, and x squared here is 0, and x squared there is 0, 0, x squared. X squared and x squared. So x squared is 1, 2c is 0. Now let's move on to our letter number 2 here, which is x. If a here is x, let's say a here is 0, b here is 2 because 2x, and c here is just 1 and 0, and let's now find the constant. So if in a the constant there is 9, let's put 9. In b there are no constant, let's put 0. In c this is negative 1, and letter d here is 3. Now we are ready to find. So x here represents our x squared here. So our first here is x is equals to 3 over 8. Our x here, you see it, x. Our y here represents our x, so y is equals to negative 3 I mean over 16. And lastly, our c here is equals to 3 over 8. Now we have our values for our problem here. So this is a, this is b, and this is c. Now by putting this equation here, let's just say here. By putting this equation here, a here is 3/8 over x minus 1 plus b here is negative 3 over 16 times 2x over x squared plus 9 plus c here is 3/8, so 3/8 over x squared plus 9. Now by integrating each of them, our answer will be equals to 3/8 ln of x minus 1 plus negative 13 plus this is negative 13, no, negative 3, I mean negative 3 over 16. Now by covering this up, so by using the U-sub here, we see 2x over x squared plus 9. U here is equals to x squared plus 9, and our du, let's see it, wait, there, no, the light here, let me put it here. Du of this, the derivative of this is just equals to 2x dx, so du over u is just equals to ln of u, which is ln of x squared plus 9 plus 3/8 ln of what is this, ln of x squared plus 9 plus c. So this is our answer for our case number 3 in quadratic factors, I mean. Now let's move on to the last type of technique of integration, which is multiple integrals. So in multiple integrals, we must solve first what is inside the first integration. Let's say here, it's up here, let's say this is a double integral, and this is just equals to ab and ab. So in multiple integral, let's solve first the value here, let's say xy dx over dy and dy, I mean. Let's solve first the value of the first integration, then let's say this is our first integration, x and dx, and then after we integrate the first integration, that's when we also integrate the answer from our first integration in order to get the final answer. Now let me give you an example here in order for you to understand more. And let's say here the integral of 0 to 3 and 0 to 2, let's say 2x squared 2y, no, let's say just 2x squared dx. So first we need to integrate this part. So x squared, let me change the problem, 2x squared times, let's say y squared dx and dy. So first we need to integrate this part. So dx here, so y squared is just constant. Let's take that out. Y squared integral of 3 over 0 times the first integration, which is we do now, and let's say y squared equals to 2x squared. So the integral of 2x squared is just equals to 2x raised to 2 plus 1 over 2 plus 1, which is equals to 2x cubed over 3. So this 2x, the integral of our first integration is 2x cubed plus 3. So times 2x cubed plus 3 from limits to our first integration here is 2 and 0. So 0 to 2, I mean. Now we substitute the value. So this will become the integral of y squared dy from limits to 0 to 3 times 2x cubed here. 2 times 2 raised to 3 just equals to 8. 8 times 2 is 16 over 3 is just equals to 16 over 3. Now by multiplying this, by simplifying this even further, our answer here is integral of 16 over 3 y squared dy. Since 16 over 3 is constant, we take that out here, and times the integral of y squared is just equals to y squared plus 1 over y 2 plus 1 is equals to y cubed over 3. So times y cubed over 3 from limits to 3 and 0. So this will just becomes to 16. 3 raised to 3 is just 3 times 3 is 9 times 3 27. 27 over 3 is just 9. So this will become 16 over 3 times 9, which will equals to, let me get my calculator. 16 over 3 times 9 is just 48. So this is our answer for our multiple integrals. Now let's move on to problem number 2. Let's say we have here a triple integral. Let's say 2, 0, 3 raised to 0, and let's say 2, let's say 2, or let's say 1 over 0, and the integral of x squared, let's say here x cosine of y dx. Yes. So dx dy. So first we need to integrate this part x and dx. So the integral of x is just equals to x squared over 2, but first we put here 2, our integration here, and cosine y is constant because we are referring to dx. So cosine y dy times x squared over 2 with limits to 1 and 0. So this will become 1/2. So 1, substitute 1 here, 1 raised to 2, just 1/2, and the integral of 2 raised to 0 times the integral of this part here, integral of cosine y dy is just, let me see, so the integral of cosine is just equals to sine y dy, sine y dy, sine y from limits to 3 and 0. Now let's change this to x. So this is x. Now this will become sin x. Oh no. Let's just stick with double integration, and we have our next example with triple integration. So this is our last problem for double integration. Let's erase this. So sine here from limits to 3 and 0, which is our second integration. This will become 1/2 times sine. Let me get the calculator here. Sine 0 is just 0 to sine 3. So let's just say is 1/2 times sine 3. This will become, our answer is equals to 1/2 times sine 3. So our answer will become this 0.026. So now for our last example, which will become a triple integration. So pi over 2 0. Oh no, not this. Yeah. So the integration of 1 raised to 0, 2 raised to 0, and 3 raised to 0. Integral of x, y cubed, z squared. So this will become first dx with respect to dy and with respect to dz. So first we need to integrate the x, which will equate to 1 over 0 from limits to 2 0. Y cubed here and z squared are constant, so let's take that out, times the integral of x here is just equals to x squared over 2 from limits to 3 and 0. So by putting this here, integral of, so 3 squared is just 9 over 2. So since 9 over 2 is a constant, let's take that outside. 9 over 2, and then the integral of 1 over 0, integral of 1 over 0. Now second integral we need to find is the y respect to dy. So since z squared is constant, let's put it here, dz times the integral of y cubed is just equals to y4 raised to 4, over 4, with limits to, our second integration here is from limits to 0 to 2. So this will just become a 2 raised to 4 is just 2 times 2 4 times 2 8 times 2 16. So 16 over 4 is just equals to 4. So 4, let's put here first 9 halves times 4. 9 halves times 4 times the integration of our last equation here, which is z squared. So the integral of z squared is just equals to z cube over 3, since by using the general power formula, n represents our exponent, so n plus 1 over n plus 1 here, which becomes 3. So by integral of 1 and 0. So by moving this here, 9 times 4 times 1 raised to 3 is just 1, so times 1/3. So by calculating this in my calculator, our final answer will become 9 halves times 4 times 1/3. Our final answer here is just equals to 6. So that is for the techniques of integration. First we discussed the integration using substitution. That is done, that is already finished. Integration by parts, that is also finished. Integration using trigonometric substitution, that is also already tackled. And partial fraction, and our last lesson here, which is multiple integrals. So if you have any question, just feel free to comment and also press like. So that's all for today's lecture video, and thank you for listening.